I did an audit not long ago. There was 225 servers that were powered up that hadn't run any data in probably 8 years. So
I guess the answer to your question is it depends, right? You can't when you broadly say it's going to be more dense, it's going to be less dense. There is a place for high density, clearly. There are some applications where it really makes sense environmentally and infrastructure-wise, where the cost is really, really high per kilowatt. But the two biggest challenges are most customers don't really know where they're going to be. So they need to be prepared, they need to be flexible. So the flexibility in the infrastructure that you are able to scale as you go, upscale, downscale, or scale redundancy is becoming much more prevalent. Right?
And I think another hazard too is that a lot of people are getting information on where they're going to be off the internet. The internet can be an amazing tool, but it can be some absolute garbage.
There's nothing better than having a good planning, business planning session. See what really matters to your business, what needs what availability, right? What needs what kind of support on the infrastructure side.
Right.
And any comments on that, or anything you want to add?
One of the things that is absolutely realistic is not knowing what you have running, how much power each one of those units that is running is actually consuming, and then how much cooling you need to put against that. You can recover a great deal from what you've already got by actually doing these audits, getting some of the granular data and looking at that. So you can actually gain additional capacity by accurately measuring what you're using now and actually going through that audit process. It's very important. A lot of our clients have found that we've been able to generate 40% of additional cooling capacity with the existing infrastructure. Then at the same time, if you start to knock down the amount of IT load you have by consolidating, virtualizing, and auditing, you can actually find that you've got a great deal more capability within your existing center than you had before.
So as we talk about centers and the evolution of centers and what's happening, you can't have a conversation without the word modular or the word container coming into the conversation. And everybody uses them interchangeably, and every data center provider and every infrastructure provider and vendor has a different thought or theme around that. So really, what is happening? What is modularity in your mind? What is containers? Who wins in this battle? And what are you seeing out there? How does it apply to your businesses?
which way we go?
Whichever way you want. Whoever like to jump in first. Who has the mic?
Oh, you got the mic. Go ahead.
Well, you got the mic. Go for it.
We actually started looking at modular data centers for a few customers, and probably one of your competitors, actually. So it's interesting.
We don't have any.
You don't have any, Chris? Okay. Actually, these guys are new
Define
here.
modular first. Right. That's what I want you to do. What does that mean?
So modular.
We say we've been building in a modular environment since 2002. But all of a sudden,
so we're talking about these containers, right? These.
No, I don't know. But some of these containers and modulars.
So what does modular mean?
What does it mean?
So it's like a pod, right? It looks like a trailer, and it has all mechanical and electrical built in. So you take these units, these modules, and you can ship them to a location and plug them in to that facility's power, and you have an extension of your data center, or you can co-locate them as well. You know, we can put them in your facility, or put them in another facility. It's not a new concept. Sun Microsystems has been doing this for years with their pods, 18-wheeler pods that they had years ago.
But isn't modular also, building out the core infrastructure for a facility and then building out in pods?
So it's two different concepts.
That's what I'm saying. Right. That's why I think to educate the audience, there is a difference between modularity and containers.
Right. One of the key characteristics of modules that I like to use, and actually it's part of my presentation a little later, is it's pre-engineered and pre-designed to some degree, and pre-manufactured and pre-tested. Those are, I guess, kind of some characteristics of a module, whether you want to call it a container or a skid or whatever you want to use.
The customers that we're dealing with now, a lot of them do have that trend to modularity just for that purpose, so they don't have to re-engineer the wheel. If they get a nice model based on power, cooling, storage, connectivity, all they have to do is duplicate that in sort of a pod-like growth fashion, and there are efficiencies associated with that.
And that's true, whether it sits in a container or not. The idea is to put in what you need. If you've got a room with 20 cracks feeding it, you probably don't need all of those day one because you're not going to fill the room up unless you're doing a wholesale move. So it makes sense to use the capacity as you have it.
Right.
Capital preservation.
Exactly.
Okay. Let's talk a little bit about cooling, what we're seeing happening there. And Carrie, you mentioned, it's been around for years, way back, since IBM had liquid cooling to the server, essentially. What else is happening there? What should folks be aware of in terms of cooling the data center environment? Any trends we're seeing that are new on the horizon?
Containment is a big word.
We see
containment. Is that?
Yeah, containment, any form.
as Jeff said from Vigilent, right? We find that a lot of data centers are actually overcooled, and that there is additional cooling capacity as well. And the trend that I've seen is that people are trying to push the set points to the upper ASHRAE limits. You have to be careful when you do that, though, so that you don't introduce risk in that process. And to minimize your risk, it's back to that monitoring, back to really understanding your environment not at a room level, but at a rack and at a U level, to understand and make sure that as you increase that set point, you're not creating, you're not exceeding manufacturer specs at certain hot points within the data center.
It's not really just manufacturer specs, though, because as you raise the temperature to ASHRAE limits, if you have legacy equipment, all you're going to do is turn up the fans in your servers. So you really get an offset. You're contradicting what you're trying to do.
Exactly.
So you have to find that little sweet spot, and it may be that you have certain areas where that works, you have certain areas where that doesn't work. And I think the variable load is really the big thing in data centers, because nobody goes in with all one type of server and say, this is going to run every application I have. Because you have applications that say, forget you, I'm not running on that platform.
You hit the nail on the head, because the newest, but I just read for Intel servers or any kind of chip manufacturers, is that they're going away from, or they're working toward a one-to-one scalability where the processor doesn't do any work, it doesn't consume any power. But right now it does like 60% of its full state, so the variability is much, much higher going forward.
Well, and if you look at like PoE that they're working on, we can have DC data centers and DC servers, within the next few years, which is definitely more energy efficient. So I think the whole thing is that you have to be as variable as what you run in your data center.
Yeah.
And why haven't we moved quicker to DC? I mean, the service providers, everything is DC based. So what's been the holdback? Is it the server manufacturers and storage manufacturers? Well, why hasn't there been more of a move from enterprises moving to DC power?
We have two DC only data centers in the US, and they're both run by the government because they're the only ones that can afford them right now. So if you look on the telco side, there are some industries that have done a lot of DC type applications, but if you look at the power that's required, and typically with PoE Plus, it's going to be delivered over a data cable as opposed to some other cable. So there's work going on in IEEE looking at that right now, but certainly we want to make sure that it's safe and it's going to work. But there is a change from switch manufacturers, there's a change from server manufacturers, and that's a huge R&D expense. So for the ones that have not traditionally played in that space, it's a massive re-engineering effort for them.
In the data center as a whole, how much is the gain in efficiency using DC over AC? I thought it was like in a single percentage, right?
It depends on what wattage you're running at. The higher your voltage, the less efficiency that you gain. But if you're not converting AC to DC, then you don't lose that in the convergence, right? So, but it depends on what you're supplying to begin with. Some voltages are much more energy efficient than other voltages. So
then I guess the other thing is the risk associated with this technology, right? It's just not out there enough for people to trust it yet.
Sure. Nobody wants to be bleeding edge. Cutting edge is fine. Bleeding edge, not so good.
Any questions yet from the audience? Come on, this is audience participation. Questions?
Yeah, you're referring to high voltage, 500 volt DC power as opposed to the NEC 48.
Sure.
There's NEC 48 servers that run today, but nobody seems to be using those. And
Well, a lot of that though is because they're dealing with existing infrastructure. It's expensive to change out an existing power infrastructure to something else. You've got PDU whips that run all over, you've got bus systems that are run all over, and it is a change to change out to the higher voltage system, but there's definitely a shift going that way, particularly in new builds.
Any other questions or comments yet? Okay, then I guess I'll keep asking questions. So let's talk a little bit about, we do have one in the back.
I don't have the microphone, so I cannot be on.
I'll repeat the question, so.
Okay. Do you see any trend going towards the aisle containment, and what would be the preferred, and why the cold aisle containment of the hot aisle containment?
So the question is around containment and what we're seeing around hot aisle containment, cold aisle containment, or what the trends are, or what are the best practices around containment. Someone want to take that first?
I would say internationally, because we don't sell containment systems. So I'll just tell you what I'm seeing in data centers. But internationally, it really varies by country. There's some that, like in Europe, it's much more a cold aisle containment environment. Here in the US, you see a lot more hot aisle containment. I think what really the point is that you want to get that air source closely coupled with the heat source. And whether you do that in a hot aisle or cold aisle, you know, there's some changes. The European Union just put out a thing where they want, by 2015, 20% of their data centers to run at 40 degrees centigrade, Celsius, which is in Fahrenheit, really darn hot. So, you know, but the idea is to get the cooling closer to the equipment. So again, you have that scalability and you have that variability. But certainly for higher density zones, hot or cold aisle containment is definitely high. Ducted systems are definitely high.
Yeah, we're seeing the same. Yeah, cold aisle for high density blades with hot aisle return. Absolutely.
Well, I guess it depends. Like retrofitting an existing data center, cold aisle containment may just be easier because you already have the perimeter cracks in there. Building a new data center, I would argue that hot aisle containment is probably better because you get higher return temperatures through the cracks, better efficiencies that way, and more flexibility in where you can place your load in the space. So it's not an easy answer as in one is better than the other. It depends, but generally speaking, the more efficient way, I would argue, is hot aisle containment. Overall, more efficient.
I would tend to agree with Axel as well, because if you happen to lose cooling for whatever reason, cold aisle containment is going to do you no good. Having hot aisle containment, at least you can still inject, so you have less risk of a thermal.
So hot aisle containment is?
It'd be great if you could do both, right? But I'm just saying, if you have a high density application, you lose cooling, you have nothing to contain cold aisle containment. Hot aisle containment, you're still rejecting the hot air from the facility, so you have a chance to recover.
And then you have other things too. You've got rear door heat exchangers that are getting real popular now. You've got air side economizers, water side economizers. You've got rebates from energy companies getting you into those technologies. So an existing facility is always going to be a little bit different than a greenfield.
You'll see sites where they have the cold aisle or hot aisle containment, and then half the rack is wide open. There's no blanket.
Which undoes the way this stuff works, right? Yeah.
Thank you.
Did that answer your question?
Yes.
Okay. Well, let's change gears for a minute and talk a little bit about standards. I mean, we heard about PUE earlier today, and PUE 2.0 or 3.0, what they're calling it, and there's the OSHRAE standards, and everyone has different assessments of the different tiers for data centers. If I'm an enterprise and I'm looking to outsource my data center to a co-location facility, or whether I'm looking to build my own new data center, how do I think about this? What do I look about? What do I think about from the standards, and what do you folks look at as really are the critical measurements around data center and data center efficiencies and things of that nature?